So now we're going to switch gears a little bit and look at the periodic table. We've already looked at isotopes, atomic theory, now we're going to look at the periodic table. This should be a review. If not, you really need to look over this stuff. When we look at the periodic table, the rows are your periods. Okay, so rows go across, and then columns, which are vertical, are groups, also called families. Elements in the same group or the same family have similar chemical properties. So all the halogens, fluorine, chlorine, bromine, iodine, all have similar properties, just as all the alkali metals have similar properties. So again, as mentioned, when you look at chemical properties of elements, you notice a pattern. All of the alkali metals, lithium, sodium, potassium, are soft reactive metals, where the noble gases, group 8, are all non-reactive. That's why elements in the same family or group have similar properties. So groups in the periodic table. These 5 groups are known by their names. These 5 groups you need to know the names for. So group 1 are your alkali metals, group 2 are your alkaline earth, group 6, this is probably a new one, group 6, which is oxygen, sulfur, selenium, tellurium, those are the chalcogens, and again that's probably one that's new, and then 7 are your halogens, 8 are your noble gases. These 5 groups you need to know their names. And nonmetals, right side of the periodic table, except hydrogen. Hydrogen is over with the metals, even though it's non-metal, it's a gas. Metals are on the left side of the metals, make up most of the periodic table. Metals are malleable, ductile, they exist as cations. That's because of the sea of electrons, which actually accounts for their excellent conductivity properties. And some of them, you notice, have such weird symbols, like antimony is SB, copper is Cu. Why are they so weird? Well, that's because of the Latin names that they come from. So antimony actually comes from stibium, so stibium SB. Copper comes from cuprum, that's where we get cupric and cuprous, which we'll look at later. Iron comes from ferrum, that's why it's Fe. Lead comes from plumbum, that's why it's Pb, so on. So there are a lot. Mercury, potassium, silver, sodium, tin, tungsten, they all come from Latin names. That's actually where they got the symbols. Metalloids. Metalloids border the stair-step line. So on the periodic table, you have the stair-step line. Any that touches that line is a metalloid, with the exception of aluminum. It's a metal. And then Po and At, those are your nonmetals. So polonium and astatine, even though they touch the line, those are nonmetals. So now we're going to use the periodic table to actually work with chemical formulas, writing chemical formulas, naming them, which is going to be extremely important. So chemical formulas, subscript, it tells you how many atoms you have in the compound. So hydrogen, H2, you have 2 atoms, water, H2O, you have 2 hydrogens, 1 oxygen, so on. With chemical formulas, we can have molecular compounds or ionic compounds. This is going to be important as you name and as you write formulas. Molecular compounds are covalently bonded. Okay, so molecular is the same as covalent. A molecular compounds are composed of molecules and have nonmetals. That is because they share electrons. Ionic compounds are composed of ions, and they're generally formed between metals and nonmetals or polyatomic ions. That is because they transfer electrons. Okay, so one gives electrons away, one shares the electrons. As we look at naming, diatomic molecules are going to be important. You need to know these. And off the top of your head, you need to know when you write H2, N2, O2, so on. And you have 7 diatomic molecules. Way to remember, Braun H. Cliff. And we have a song that goes along with it. Talk to anybody that was in... I'm not going to sing it for you on here because I don't want to hurt your ears. But 7 diatomic molecules, you have Braun H. Cliff. Any of these are by themselves, they occur as 2 atoms together. And then we can have 2 types of formulas. We can have the empirical formula or the molecular formula. The empirical formula gives the lowest whole number ratio of atoms. The empirical formula is the most simplest formula we can have. You can see an example down at the bottom. The empirical formula is CH2O. You cannot get it any simpler than that. Molecular formula, though, gives you the exact number of atoms of each element in a compound. So, for example, glucose is C6H12O6. Notice that is not as simple as it can be. That is the actual formula. So the actual formula is molecular. Empirical is going to be the simplest whole number ratio. Now, the empirical could also be the molecular. For example, water. Water is H2O. Okay, that is the empirical. That's the simplest whole number ratio that it could be, but that's also the molecular. So those are going to be the 2 differences. gases. So we use the periodic table when we're looking at ions. Remember, electrons are the only subatomic particle that's involved in bonding and reactivity. So electrons is what is gained or lost in formation of ions. So atoms lose or gain electrons, they become the ions. You have the cations, which are positive. Okay, remember the T looks like a plus. And you have happy cat. Cations are positive and they are formed by elements on the left side. Metals form your cations. Anions are negative, formed by elements on the right side. Nonmetals. Okay, so you have the cations, which are positive, the anions, which are negative. And you can see the most common ions on the periodic table at the top. You have +1, +2. We skip the transition metals because they can have various charges. And then we can go over to nitrogen, and then the chalcogens and the halogens. So practice problem. Predict the charge expected for the most stable ion of barium, most stable ion of oxygen. If you look on the periodic table, barium is in group 2, has 2 valence electrons. Well, it is easier for barium to lose those 2 than to gain 6, so barium becomes +2, or 2+. Oxygen has 6 valence. If you remember on the periodic table, if I can draw this, okay, you have group 1, 2, skip the transition, 3, 4, so we have +1, +2, skip transition, +3, ±4, -3, -2, -1, 0 for the noble gases. So we look and see what family it's in. Barium is +2, oxygen -2. First thing we're going to do is write formulas for ionic compounds. So this is going to be for ionic compounds. Because compounds are electrically neutral, we can determine the formula of an ionic compound using the crisscross method. So we have the charge on the cation becomes the subscript of the anion, charge of the anion becomes the subscript of the cation. If they are not in the lowest whole number ratio, divide them to get as low as you can. Again, this is going to be for the ionic compounds. You just use the crisscross method. Some common cations you should know. We have group 1, group 2, aluminum is +3. So you know the metals, you know the common metals. Then we have the transition metals. When we look at the transition metals, you need to know the possible charges. If you look over the ion sheet in the summer assignment packet, you have the full list of the ions that you need to memorize. You need to know, for example, iron can be 2 or 3. You need to know that copper can be 1 or 2. Those are very important. Notice the names next to it as well. Copper 1 is cuprous, copper 2, cuprit. All the naming stuff should be coming back to you. I'm sure you're sitting there going, oh man, this is going to be very, very helpful the entire year. You cannot forget this stuff. Same with polyatomics. You notice that lead here, lead is +2. We can also have at the bottom 4+. Okay, that is plumbate. So again, if you look at the ion sheet in the summer packet, that's going to go over all of this, but you need to know possible charges for transition metals. Now we look at anions. Again, as before, you can see most common halogens, chalcogens, and then polyatomics. Look over the polyatomics list. You need to know all of these and many more. You also need to know how to go from perchlorate, chlorate, chlorite to hypochlorite, so on. So look at that full list. If you do not have the naming packet that you got first year, I've posted that online, so you have that as well as the summer assignment information to help you through naming. So just some practice exercises. I want you to try these on your own. You should be able to get through this. So pause it, go through, find the formula. So check answers for this practice exercise. Biggest thing to note is when you have multiple polyatomics, it has to be in parentheses. It's not in parentheses, it's wrong.